In this lecture titled Visualization Typology, we are going to look at various ways by which visualizations can be classified. Typically, these visualizations can be classified based on forms, which is what mostly you would come to know that visualizations can be like bar graphs or charts, uh, a bubble diagram, scatter plot, and so on and so forth. Right? This is what most of us are familiar with. That's one way of thinking about visualizations. Mostly the formal qualities of the visualization. The second classification is based on the intention. Right? What do you want to do with your visualization? Is it to communicate? Is it to persuade? Is it to discover? Depending on that, or is it to instruct somebody to do something? Depending on what you want to do, you can also think about your visualization that will lead to that intent or that lead to fulfilling that intent. The third type of classification is based on the user experience you want to provide to the user. You want to provide an interactive experience, you want to look at a tangible experience where visualization is not just only through the visual senses, but also through an audio sensor, perhaps even touch, sensory, and so on. So these three ways of classifying visualization is very useful to think about how to go about designing visualizations. In the second part of the lecture, I am going to introduce to you a simple yet powerful framework for designing visualizations, and then I will round off this lecture by talking about the difference between data visualization and infographic. This is sometimes used interchangeably, but there is a difference between them, and it is important that we know that going forward when we talk about visualization in our future topics. So we can get started on the second topic for the course, which is visualization typology. Okay, so in the first class we tried to answer some of these questions. You remember, right? Why do we visualize at all? To convey information through a visual representation in order to, from a very simple map, record, or summarize, to maybe even inspire, advocate, persuade change people's mind, and tell a compelling story, right? And then it could fall anywhere in between them. And so today's lecture is going to be about what are the different ways by which we can think about visualization design in a more systematic manner, right? So what are the methods or frameworks or processes that are available to you, okay? Because in a formal course like this, we don't want to be just designing anything, right? Which is exactly what you did in your first exercise. Remember, I just threw a data set at you and then asked you to come up with a visual representation of it, right? And you did not have any framework to think about how to go about designing for it, right? So which is where the frameworks become very useful, right? You know what a design framework is, right? And it's just a process, a model by which you can be assured that there is some kind of a quality is met for your output, okay? So that certain things are taken care of, you don't miss out some critical steps and so on. The MDes students during their P1 presentation talked about one such model, right? Many students use this divergence, convergence, the double diamond model. You might have also heard about it, right? In the design process, where you converge, where you generate a lot of ideas, and at some point of time you diverge first and then converge, and then again diverge again, and then reach the final solution. One of the most common design framework or a model that is available to you is the cyclical model, right? Which is you design, prototype, test, and then go back to design again, and then do it in a cyclical iterative manner, so that in every iteration you achieve a little bit of perfection towards a optimum solution, right? So these are various methods. There is nothing like one model is the correct model, right? Because these are just processes, right? It's a process tool. Think of when somebody talks about a framework or a model, it is not cast in stone, it is not something that is proven to be correct all the time, but it works most of the time for certain kinds of situations, okay? And that's what frameworks are all about. Okay, is that clear where the frameworks come, right? So this is not some kind of a very clear step-by-step ways, only way by which you can reach a solution, right? And people always tweak the models, right? People come up with better models, which is a modification of an existing model, right? And then, you know, a lot of people do their entire PhDs on these frameworks, right? They just come up with a framework to think about a problem in a more systematic manner, okay? The whole user-centered design, about developing empathy towards the user, and that's one such model again, right, which is very endemic to the field or the profession, our profession of design, right? We put the users in the and put ourselves in the shoe, think about what the user wants more than anything else, and then the design solutions that come out are more user facing rather than system that satisfies the system or the person who provides the solution, right? It's about the user. So we're going to be looking at a few of such frameworks. I'm not going to give you just one framework and then say that no, anything that you design, any visualization that you design has to be like this. It is up to you to choose, pick and choose the model that works for you the best, okay? And I also tell you what kinds of models work best in what kinds of situations or what kind of problems, right? So in that sense, you know, this is the process lecture, right? So if there is some kind of a way by which I can do visualization so that I will be assured of certain minimum quality in my outcomes, you have to follow one of these processes. And when you get better at doing more of them, you will also develop your own insights, your own practice into how things work, and then you might want to tweak on existing models, or you might even come up with an entirely new model yourself, okay, that works for you, okay? What you did yesterday was a model or a framework free exercise, okay? And that was intentionally given to you just to see how you think about it, okay? Many of you came up with this Murray diagram, right? Which is something that is a standard way of representing timetables in visualization. You might not be aware of that, but it's one of the most economical ways of doing it, right? And some of you asked some very pertinent questions also, right? I think Shweta asked, you know, when this is about the users who are passengers, but will this be too complicated for them to understand, right? Some of you asked questions such as, is this representation that should accommodate more trains, more timetables into it, or is it just this only 2 trains that we have to? So when you think about something that represents only 2 trains versus something that can accommodate 10 more trains into the same representation, the way that you think about the solution is also different, right? Okay, so now we can divide or classify visualization based on several factors, right? Now, one of the ways by which we can classify is based on the form, okay? The formal qualities of the visualization. How does it look, right? What shape it has, okay? So temporal data visualization track time series data, the performance of an indicator over a period of time. They are normally feature lines that either stand alone or overlap with each other with start and a finish line, right? So any kind of temporal data has a very linear form to it, right? You can imagine that. In fact, yesterday you worked with the temporal data, right? At least one variable of your data set was temporal in nature, right? Start time, end time, so it's always linear, right? It always moves in one direction and you cannot rearrange them at all. So line graphs, bar charts, Gantt chart. So some of you did what kind of appeared like a Gantt chart, right? Which is like this. And I also saw in your P1 presentation, many of you will also include a Gantt chart in your P1, in your P2 projects as well, about how you plan to work on your project, right? You know, in the first week I'll do research, second week I'll do this, third week I'll do this, fourth week I'll do prototype, fifth week I'll do, you know, testing, etc., right? Time series sequences, timelines, line graphs. So these are all the forms this temporal data takes. Okay. In fact, the data kind of dictates the form that it will assume eventually. So sometimes it could be even spiral in nature, right? If you saw yesterday Nightingale's visualization of a 12-month cyclical data, right? And she had put it as 12 segments, and then it was going around like this. You can fold multiple years also in the same circle, right? For example, it could go one circle and then go another circle, another circle, another circle, and so on, right? I saw one interesting visualization of the polar ice caps and how much area that it used to cover several years ago, several decades ago, and how it has been reducing, right? That's one of the major most visible part of what is happening with global warming, right? So the caps are melting, the size of the Antarctica and Arctic land mass is reducing, or the ice mass is reducing dramatically, right? So there was a very interesting visualization. You can just look at or just Google this term death spiral, okay, plus polar ice caps or something like that. You will come across this visualization, where with real data they have measured the area that ice used to be covered and how progressively over the last 100 years it has become smaller and smaller, and there is a kind of a spiral that you can see in the data. Okay, so they have marked it. So every monthly data is available over many years, and if you look at it, it's kind of a death spiral, really, right? So and it semantically also it's very meaningful, right? So from what used to be such a big landmass, now it's become such a small landmass, right? And there is also projections on how small it will get eventually, right? In another 50 years, it will be even smaller than that. In another 100 years, it will probably completely disappear, right? So the message comes across visually very clearly. Okay, then there is hierarchical data. Visualizations are visualization order groups within larger groups. They are best suited if you are looking to display clusters of information, especially if they flow from a single point of origin. Okay, so classic example of hierarchical data is the tree diagram, right? You start with the stem and then branches and further branches and further branches and so on. Okay. Ring charts, which are variations of that, where the center is in the where the origin is in the center, instead of at the top or bottom. So it kind of radiates from the center. So you have one single origin, then which branches to maybe 4 or 5, which further branches to 12 or 15, and so on and so forth. And sunburst and ring diagrams are kind of very similar in nature. Okay. So what you see is a tree diagram here, which traces back the origins of the SARS virus, COVID-2 virus, which is somewhere here. We discovered it, early 2000, somewhere 2019 or so, and the possible origins of how it separated from the main branch back about 800 years, 900 years ago, or almost 1,000 years ago. The SARS-2 COVID-2 lineage might have separated centuries ago from that of SARS-CoV, a cause of. Okay, so that is hierarchical data. Okay. Okay. Then we have network data sets connect deeply with other data sets. Network data visualizations show how they relate to one another within a network. In other words, demonstrating relationship between data sets without very wordy explanation. So examples of that are matrix diagrams, node link diagrams, word clouds, alluvial diagrams, or also called as Sankey diagrams, and so on. Okay, so you can find more examples of this form-based classes at this link. And the last classification that we do based on the form is geospatial, relate to real life physical locations and overlaying familiar map with different data points. Okay, so flow map that we saw of Napoleon's march, density maps which show say for example temperatures or population or temperatures in different populations and so on, right. Cartograms are a variation of geographical maps. We will see what they are, when we come to Thursday, Friday sessions on geovisualization. And heat maps or what you distribute or average out certain parameters, certain variable across the geographical region. So it kind of, suppose you want to for example represent the literacy levels in different states in the country. So you will then map say on a gradient scale of colors that would indicate from the most literate state to the least literate state and so on. Okay. So that's what is a heat map. Okay, so then we can also think about classifications. So this is the most simple, right? If you look at most of these authoring tools that are available for you to create visualizations, which do not require too much of technical expertise, right? Such as say Flourish or Data Wrapper or Tableau, right? You might have heard about these tools. These are simple to use authoring software or web based tools that given a data will allow you to pick different kinds of charts, and then you might be able to customize those charts a little bit. You can customize the colors, you can customize the text, labels, etc. And then we'll give you some standard templates by which you can visualize them, right? And the way that they operate is based on mostly the form, right? It will detect that it is an hierarchical data, or it will ask you to specify what type of data it is, right? You either say that it's a network data, or it's a hierarchical data, or is it geospatial data. Then it will figure out what possible visualizations can happen with that, and then suggest you again a few set of options for you to select, and then it's a very wizard based approach to the whole thing, right? So you tell the software what your data is about, and then it will suggest you the forms, and they operate based mostly on this form based classification, right? So typology here is purely the form of the data and then the corresponding visualizations for it, okay? And there is a most standard approach that everybody takes, right? But you can also think about classification based on the intention, all right? Whether it is to analyze something or is it to present something, right? Or is it to explore something and so on, right? So the intention could be very different as well. So trends, time series. So you want to show trends, right? You want to show correlation, you want to show distribution, you want to show part to whole, you want to show ranking, right? What is the most populous state versus least populous state, what is the most populous or most literate state versus least literate state. So here most of this correspond to the analytical part of it. You're analyzing, you're trying to analyze, right? Or you want to show spatial relationships, you want to show flow. So you look at that, you're using the similar kind of charts that you used in the form based classification, but the intentions are different, right? You're kind of looking at the intention of what is it that you want to. I want to show part to whole, okay? I want to show the spatial relationship of a particular location and how it relates to how far it is to other locations. Is distribution, correlation. So we saw correlation, right? So the two charts yesterday between the correlation between the birthdays and then the performances, right? So it is through two charts, I mean you have to make that connection, right? It's not evident with just one single chart, only two charts make that difference, but put next to each other with identical encoding, it becomes very obvious what the correlation is. Then you can also classify based on what is the experience that you want to give to the user, right? So you can choose a narrative approach. The objective is to explain by giving the reader a vicarious experience of intent through the story, right? So you are letting the user live through that experience, right? So most of New York Times journalistic pieces are narratives, right? They tell you a story, okay? So they will tell you a story of how SARS say spreads, okay? So they will use real data behind it, but they will put a put characters. Narratives have characters, right? So this person goes to this crowded room, for example, and there are 15 other people, and he invects 2 other people, and then it kind of spreads like that. They want to explain a scientific phenomena, but there is a narrative to it, right? The story of the Hurricane Katrina that we saw in New York Times graphic is also a narrative, right? Although the characters there are the cyclone itself, the city, and the features of the city are the characters in that story. You saw that example of Peter Menzel's photo essay, right? And it was also, although it was not designed as a visualization narrative, it's a visual narrative, right? So there are real people in the characters. You can kind of identify with them and relate to them, right? There is so much information that is present, which is not just only about the food itself, but about how many people in the family, what kind of clothing, whether they're sitting on the floor or on the table, what is their house look like, and what is primarily their diet is, and so on, right? So they all use a narrative. It's a very popular form of telling a story, right? It could be instructive in nature, explain step by step how things work, right? Most of the exploded diagrams examples that I saw, right? Like for example, what makes the different parts in a watch, you show it through explode, or how did the accident happen. It's not really an explanation, it's not really instruction, but it's kind of explanatory, So it tells you the 5 steps that happened in the process of the accident, right? So this is what the first thing, second thing, third thing, and this is the final result. And the third type of experience that you can provide your user is exploratory. So you do not have a narrative yourself to tell. You do not have a specific instruction to give. You're not explaining anything, but you're providing a way to access some data so that people can make up their own mind about it. Okay? So they are very exploratory in nature. And some of the examples of that work you can find in my website. Many of the election visualizations are very exploratory in nature. So we have this huge data coming out of the Election Commission of India, and we provide interactive ways to compare and contrast multiple things, various parameters, right? We do not know what an election analyst will be looking at, right? But we provide them with a lot of ways to do that, so that hopefully they can draw their own insights from it. Okay? So it is very open-ended quest, and the purpose is that how can you provide the maximum exploration visually possible, right? The neurons visualization that we have done recently, or maybe a few years ago, was about that. Okay? So the problem that came to us was that we have some very exciting new information, new data coming out of neuroscience. Okay? What used to happen was that there was a very approximate measure of how many neurons were in the brains of various animals, right? So what they would do is take a small section of the brain, count the number of neurons in it, and then multiply it with the total mass of the brain. Therefore, we'll arrive at some kind of a approximate number of what the. So that was the traditional understanding of how many neurons were it. And then you might have heard about how human beings have the most neurons, etc. But we do not have the biggest brains. Okay? And the neurons are directly proportional to how smart a particular creature is, right? Now what has happened is the new technologies have allowed for very precise measurement of the neurons, right? So there is some techniques now which will precisely count the number of neurons in species in a specimen, right? And what they discovered was very interesting, that the neurons are not equally distributed in the brain. Okay? So there are parts of the brain which have more concentration of neurons, and some parts that are less concentration of the neuron. Okay? So the prefrontal cortex, right, which is where the executive part of the brain or the decision making part of the brain, right, the human beings have the most number of neurons, right, even more neurons than an elephant, whose brain mass is much larger than. So that explains why even though elephant has a much larger brain than the humans, it is not as smart as the humans, simply because we have more neurons in our prefrontal cortex than what the elephants have in their prefrontal cortex, right? So this is all new findings that happened in the last few years. That is very exciting for the researchers in that field, and now they want a tool, or they want to visualize multiple parts with multiple species and so on. Okay, so right now they do not have such a tool, something to visualize. So they kind of take one and they have to do it manually and figure out what is the ratio, right? So, and brain also contains both neurons and non-neurons, right? And then all these things. So there are various parameters in this count, and they wanted a tool that allows them to compare, basically put different things in the numerator and the denominator, so that they can derive the various ratios. Okay, so we created a tool that allows them to do it. So it's up to them to make up whatever they want. Okay, they might be specifically looking at some species, they may be looking at a few species to compare them, and they may be looking at specific part of the brain and only comparing them and so on. We do not know, but as long as we provide them the tool that allows them to make these comparisons and visualize it, it's a very useful tool for them. So that's a very exploratory. The experience that we are trying to provide is one of exploration. Okay, so most of our election visualizations do not categorically say that some party won because of this. Okay, we just give them option to compare many things, right? And then depending on the level of expertise, the person who's exploring them will draw their own conclusions about such results. And then the last of that category is called simulatives. Allow the user to experience the intent, usually a real world phenomena, right? So this is becoming very popular type of visualization these days, right? So one recent example that I saw came out in Reuters is that you can simulate conditions of a COVID spread based on some parameters. Okay, the parameters are like how many people are infected, what if they wear a mask, what if they don't wear a mask, right? How close are they in a closed space, or they in outdoor? So these are conditions that you can on and off, right? You can filter out and then see what the outcome is going to be, right? So you can simulate many conditions and then see what would be the possible results. Okay, a lot of disaster management and relief operations are based on these kinds of simulations as well. Okay, several years ago, one of my MDes students did a project on flooding simulation in Mumbai. Okay, if you recall, in 2005 there was a major flooding that happened. It was considered to be the rains of the century or something like that, where a lot of things combined together to cause this major havoc. Okay, so historically it was too much of rain that fell within the 24-hour period. It was also the high tides season, and the drainages of low-lying areas used to have some pumping stations which pump out water rapidly from low-lying areas out into the city, and many of them or some of them failed. Okay, so because of these multiple factors all happening at the same time, it turned out to be a major flooding disaster. Several people lost their lives, crores of rupees of property was damaged, etc., etc. Right now, there is so what the student did was he kind of simulated these things. So for example, you can control the amount of rain that could fall, and then control the tide levels, control the capacity of the pumping station. Say for example, you can turn off a few pumping stations, turn on only few of them. What will happen, right? So for every case, you can simulate what would happen, so that the preparedness can be planned better. Okay, so you can think of many situations like that, where such simulations might be very useful, right?